So yesterday we learned one postulate and 3 theorems that tell us information about these special angles, right? They all start the exact same way. If 2 parallel lines are cut by a transversal, and then what changes what followed. So if I said, then corresponding angles are, what would you say? If 2 parallel lines are cut by a transversal, corresponding angles would be? Congruent. Good. Alternate interior angles would be? Congruent. Alternate exterior? Congruent. And same side supplementary? Same side supplementary. Same side interior supplementary. Okay? So with number 1, 2, and 3, it just says to identify which theorem justifies it. So 3 and 6 have what relationship? Good. So this would be the alternate interior angles theorem. And then 4 and 6. So 4 and 6 have what relationship? Same side interior. So this is same side interior.
So that's not corresponding?
Corresponding. So the way I identify corresponding is if you draw a little box around where the 2 lines intersect, and that number is in the same location of the box. So if I said 2, 2's in the top of that box, then 6 is corresponding to 2. And then 4 would match 8, 3 would match 7, and 1 would match 5. All right, then number 3 says, if the measure of angle 2 is 115, so we're saying this is now 115 degrees, find the measure of angle 7. What would that answer be? 115. Why is it 115? Good. Alternate exterior angles theorem. Yes, everybody see that? Okay. 4 says find the values of x and y. So now we're bringing in a little bit of our algebra skills in here. So the parallel lines are the top and the bottom. And you actually have 2 transversals here. You've got one that's like this, and you've got one that's like this. So if I want to find x, I have to find another either single angle or pair of angles in which it has a relationship with them. So if I ignore that red line for a moment, what's the relationship between this whole angle and 6x? They're not alternate, right? They're not corresponding because they're both inside, which means same side interior. What's true about same side interior? They add up to 180. So this angle plus this 30 degrees plus 6x is going to add up to 180 degrees. So I'd get 2x plus 10 plus 30 plus 6x equals 180 degrees. Salvador. The y, well, after I find the x, then I got to go back to find the y. So this is going to give me the x, right? So 2x plus 6x is 8x. And then 10 plus 30 is 40 equals 180. Subtract the 40. 8x equals 140. And then divide 140 by 8. And it would be, I could reduce it, right? So 8 does not go in evenly into 140. You can open it from, yeah. So I can just reduce it. I could start with 70 over 4 and then go 35 over 2. So I combine my terms in the top. Are you good on that step? So I divided 140 by 8, and it doesn't go in evenly. So I reduced it. Both of them are divisible by 2, so I started there, brought it to 70 over 40. Both of those are divisible by 2 again, so I went to 35 over 2. Or 17.5 or 17.5. Any of those answers are okay.
So it doesn't matter if we leave it in fraction?
As long as it's simplified.
Yes, ma'am.
Oh, okay. All right, so that's my x value. I still have to find the y value. Okay, so let's clean this up a little bit. Now the y is in here. And I'll tell you there's a couple ways to do this, but one is using its alternate interior angle match. So what would be true about that 2x plus 10 and the y plus 10? They're congruent. Now I don't know the y, so y plus 10 would equal 2x plus 10, but I do know the x, right? So 2 times 35 over 2 plus 10. Yep. So then y plus 10 equals, these cancel, which is the only reason why it's easier to do that. And I get 35 plus 10. Y plus 10 would equal 45. And then subtract the 10. And y is 35. So sometimes you've got to use more than one angle pair relationship to get to the end, to break it apart. Mm-hmm. All right, number 5 says the picture shows a plant trellis. If the measure of angle 1 is 82, find the measure of angle 2. So they just take what you know and apply it to a shape. Okay, what would be the measure of angle 2? 82 degrees. And how do you know that? Good. Corresponding angles, and that's the one that's the postulate, right? So corresponding angles postulate, if it asks you to write it. So be careful, make sure you read your instructions. Like on the homework it said, find the value of the angle and state the postulate or theorem that justifies your reasoning. So you got to make sure that you include that stuff. So chapter 3, section 3 is called Proving Lines Are Parallel. So we're basically taking everything we talked about yesterday and flip-flopping it using the converse. Every theorem we talked about yesterday started with the same words that were, if the lines are parallel, then, and then we went through the 4 angle relationships. Now we're switching it. We're saying if the angles have some sort of relationship, and that's going to change depending on what type it is, then the lines are parallel. So you're using this information to prove that they're parallel. So the first one is called the corresponding angles converse postulate. And it says if 2 lines are cut by a transversal and the corresponding angles are congruent, then the lines are parallel. So all of these are going to end the same way. The end goal here for all of these is that the lines are parallel. So if the lines are cut by a transversal and the corresponding angles are congruent, then the lines are parallel. So if you were given that diagram and it said, like, what could you conclude from that diagram? You can say that because angle 2 and angle 6 are congruent, J is parallel to K. And your reasoning would be this, the corresponding angles converse postulate. So the converse is the one that flips the order. Okay, this is called a parallel postulate. And it says through a point P, not on line L, there is exactly one line parallel to L. So all this means is if I have a line, and then I have a point not on this line, so let's say this is line L, and this is point P. And I ask each and every one of you to go to the board and draw me a line through P that's parallel to L. Every single one of you would draw the same line. The length may not be the same, right? But a line goes on ending. There's only one way to draw that line, and it would be straight through P that is parallel to L. So that's all this means. There's only one line that can be drawn that would be parallel to L and passes through P. Okay, so the corresponding ones, remember the corresponding is a postulate. The rest of these are theorems, but they are the same pattern. So in yesterday's section, we said if the lines were parallel, then alternate interior angles are congruent, And if the lines are parallel, alternate exterior angles are congruent. Now we flip-flop it. And we say if two lines are cut by a transversal and the alternate interior angles are congruent, then the lines are parallel. Or if we have two lines that are cut by a transversal and the alternate exterior angles are congruent, then the lines are parallel. So those are both the converse to the initial theorem. All right, and I think your book says same side interior, so I didn't change that, but you could change that. Some say consecutive interior, some say same side interior. So you can change that name, okay? So this one says if two lines are cut by a transversal so that the consecutive interior, again, this would be same side interior, interior angles are supplementary, then the lines are parallel. So now we know 4 ways to show that lines are parallel. The first is that corresponding angles are congruent. The second, alternate interior angles are congruent. Third, alternate exterior angles are congruent. And this 4th way, which is that same side interior angles are supplementary. If any of those 4 pieces of information are true, then we can conclude that the lines are parallel. This is the last one. So the transitive property of parallel lines. So the transitive property actually applies to parallel lines. If two lines are parallel to the same line, then they are parallel to each other.
What does it mean by that?
So I'll draw you a picture. I think it's easier to see it, right? So let's say you've got 3 lines, right? And that they give you at some point that 2 pairs are parallel. Like if J is parallel to K and K is parallel to L, then you can conclude that J is parallel to L. So it's just like the transitive property, except you're applying it to parallel lines. Okay, so let's try some examples. This one says find the value of x that makes m parallel to n. So notice that this diagram is not marked that m is parallel to n, right? It's saying what value of x would make m parallel to n. So if they were parallel, what would be true about those blue angles? Nope. They'd be, wait, what's true about this one and this one? They're corresponding, and if those lines were parallel, they would be congruent. So I would say that 3x plus 5 has to equal 65 in order for those lines to be congruent. In order for those lines to be parallel. So I'd get 3x equals 60 and x equals 20. So if x was 20, then those 2 angles would be congruent, and if those 2 angles are congruent, then the lines would be parallel. Okay, example 2 says, is there enough information in the diagram to conclude that m is parallel to n? And then explain why or why not. So what's the relationship that's between 75 and 105? Do those 2 have a special relationship?
Same side exterior.
Is there such a theorem as same side exterior? No. So is there enough information to prove that those are parallel? No. Does that make sense? So in your own words, but you could say something like, there's no such thing as same side interior. Now, could you eventually prove it? Yeah, how? God bless you. Those are both exterior, but they're not alternate exterior. The only theorem we know about exterior is alternate exterior, right? But what could you piece together about that? Go ahead.
That they equal a line, so they should equal 180.
So like these 2 would equal a line, yes? Which would tell you that what's the angle above it? What would be that measurement? 75, right? Because if they're a linear pair, they add up to 180. Now, do I have enough information to prove that these lines are parallel? Why?
Because both lines are equal.
Not the lines. So lines can't be equal because you can't stop a line if you can't measure it.
Because the two angles are corresponding.
The two 75s are corresponding angles. Everybody see that? And if the corresponding angles are congruent, then the lines are parallel. Okay? So you could eventually get there, but from what they initially gave you, there wasn't enough information. All right, can you prove the lines are parallel, that A and B are parallel, and explain why or why not? So you guys try this one. There's 3 different ones. Are they parallel? If so, why? And if they're not, also, why not? All right, let's start with example A. So is there enough information provided to prove that line A is parallel to line B? Yes, and what's your reasoning?
Because same side exterior.
There's a different word.
Alternate
Good.
exterior.
So it's alternate exterior angles theorem converse. Yep.
We have to put converse?
Yep.
What is converse?
The converse is saying if the angles are congruent, then the lines are parallel. The initial theorem says you already knew the lines were parallel, so the angles are congruent. We need to flip-flop it.
So, for converse, it's just to prove that it's parallel?
Correct. So your end result with all those converses is that they're parallel. So every bit of that needs to be given. The alternate exterior angles theorem converse, or the converse to the alternate exterior angle theorem. All right, how about B?
Yes,
And what would be your reasoning there?
because they're corresponding angles possible.
Good, good. Corresponding angles, postulate, converse. So if you are proving that the lines are parallel, the word converse has to be part of it. With me so far? Everybody good? Yeah? And C, measure of angle 1 plus measure of angle 2 is 180. Is that enough information to prove the lines are parallel?
Yes.
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 How many think yes? Raise your hand if you think yes. And how many think no? Oh, and the rest of you just would leave that blank? That would not be a good idea. At least you had a 50-50 shot. That is no. Why is it no? Same side could be supplementary, or those are alternate interior. What would have to be true about alternate interior? They have to be congruent. So the fact that they're supplementary doesn't mean that they're congruent. Does that make sense? They could both be 90, and then it would be yes, but you don't know that they're 90. One could be 120 and one would be 60. These are alternate interior, and in order for alternate interior angles to prove parallel lines, they have to be congruent. So either angle 1 would have to equal angle 2, or you would have to have the 2 here to do the same side interior. All right, example 4, prove that if two lines are cut by a transversal, so the alternate interior angles are congruent, then the lines are parallel. So you are proving this theorem without using this theorem. So you cannot use alternate interior angles as your reasoning, okay? But you can use everything else leading into it. So it wants you to actually prove that theorem.
We have to use another theorem.
Exactly. So think about your overall proof, because there's not even steps there, right? And trust me, you're going to get lots of proofs. So if you're given that angle 4 equals angle 5, and again, you're not even using alternate interior angles theorem, could you eventually get to where G is parallel to H? How? So talk it out before you even give those step-by-step process. Go ahead.
1 and 4 is vertical.
Good.
Or you can say like 1 and 5 is corresponding.
Yep. So you could say 1 and 5, if the lines are parallel, then 1 and 5 are corresponding. 1 and 5 would be congruent if 1 is equal to 4 and 4 is equal to 5. Does that make sense? So I already know 4 is, and exactly, that would be transitive. So now let's put that into steps. Yep.
You know when we write, say we're using vertical angles of our reasoning, you know how we write VAT?
Mm-hmm.
Do we add like VATC, like corresponding, or?
No, because vertical angles are vertical angles. It has nothing to do with the fact that they would eventually be corresponding. They're totally separate. So the first thing I would do is what? Angle 4 is congruent to angle 5, and that is?
Vertical.
Given. Okay, then we said we know from previous information that angle 1 is equal to angle 4, or congruent to angle 4, and that reason is?
Vertical.
Vertical angles theorem, so VAT. And then we said that if 4 equals 5 and 1 equals 4, we could get to 1 equals 5. And that's transitive. Yep.
What is the VAT?
Vertical angles theorem. So a pair of vertical angles are congruent. And then if 1 is equal to 5, then these lines are parallel. And my reason would be what? What's the relationship between 1 and 5? Corresponding. So the corresponding angles, postulate, converse.
I don't understand how it's translated.
Because we said, think about what's here, combine these two together. We said 4 equals 5 and 4 equals 1. So you're using 4 to connect those other two. You're welcome. So piece this together. It says in the figure, R is parallel to S. So you already know that R is parallel to S. This one is parallel to this one. And that 1 is congruent to 3. So let's mark the stuff we know. You can go. You're trying to prove that P is parallel to Q. So before you even start working out your steps, try to figure out how you could do that. So what 4 ways do you know to prove that P is parallel to Q? Braylon.
2 and 3 are vertical.
Not vertical, but
I mean, corresponding.
think about they're on alternate sides of the line, right?
Alternate interior.
Good. So 3 and 2 are alternate interior. If we can get that 3 and 2 are congruent, then we can show those lines are parallel. Does that make sense? So try to break this apart. Like actually look at your diagram. This is when you get the opportunity to flip pages around and that kind of stuff. Let's say I looked at it this way and I saw that these two were my parallel lines and this is my transversal. Let's start there. What information do you know that they didn't give you? And that makes them what? Congruent. And then we said from the given that 1 is congruent to 3. So if 1 is congruent to 2 and 1 is congruent to 3, then what? Then 2 is congruent to 3. What's that? Transitive. And if 2 is congruent to 3, then P and Q are parallel. Does everybody understand that?
Yeah.
So it's hard because there's nothing given to you, right? There's no steps already provided.
What is transitive again?
Transitive is because both, we're going to say 1 is congruent to 2 and 1 is congruent to 3. So then 2 is congruent to 3. You're taking out the one that repeats. All right, so let's write all those steps out.
1 and 3 are alternate exterior.
No, actually 1 and 3 have no relationship to each other. They are not on the same transversal. So this, when you look at it this way, these are parallel. This is a transversal, right? And these have a relationship to those. Or this could be your transversal, and these have a relationship to these. Or your transversals can go the other way. So now you can be saying that this is your parallel line. This is your transversal, so these would all be linked, and these would all be linked. But you can't go across to the other transversal. So sometimes it's easier to kind of like take something and block off it in part so that you can see it. All right, so we said obviously we're going to need the given. So R is parallel to S, and angle 1 is congruent to angle 3, and that's given. And then we said that because R is parallel to S, Angle 1 is congruent to angle 2, and that's the corresponding angles postulate. So we already knew the lines are parallel. We're stating that the angles are congruent. That's the postulate. And then we said if 1 equals 3 and 1 equals 2, that 3 equals 2. And what was that reasoning? Good, transitive. And that if 3 equals 2, or 3 is congruent to 2, then P is parallel to Q. And the reason is, I'll get it this time. And the reason is, what was the relationship between 3 and 2? Good.
Interior.
Alternate interior. You're welcome. Angles, theorem, converse.